So hi everyone, we're going to begin with section 1.2, which is exponents and radicals. So this is kind of a review of all our exponential rules and things that we can do with our exponents. So you'll notice a little table here. It has 9 different exponential rules. So I'll maybe do a few examples here. Notice that what we're talking about is multiplying things together with the same base that have different exponents. So in a basic example of this would be something like 2 to the 5th times 2 to the 3rd. And that written out is just 2 times 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 2. So as you can see, that gives us 8 2's, or 2 to the 8th. And so the rule that's happening there, which you're probably not surprised to find out, is that we're adding together our exponents. And that's where the first rule comes in. I'll do the one below that. Similarly, if you have, say, 2 to the 9th, and you divide it by 2 to the 4th, we can do all sorts of things here. What we're going to find is that in the numerator is just 2 times 2 times 2 times 2 times 2, 9 times. In the denominator, 2 times 2 times 2 times 2, 4 times. And then what happens is we can simplify any of the common 2's. So we can simplify 4 2's from the denominator and 4 2's from the numerator, which leaves us with 5 2's in the numerator, or 2 to the 5th. So what we're seeing here is that the rule is coming from the idea of subtracting your exponents. 9 minus 4 is 5. We also have things like a to the m to the n. So for example, to not do anything too extreme here, if we have 2 to the 3rd to the 4th, that is actually the same as 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd, which, if you did this all out, would be 2 times 2 times 2 times 2 times 2 times 2, and so on, where you'd end up with 12 2's, or 2 to the 12th. So the rule here that's happening, as you can see, is a multiplication of the exponents. So 2 to the 3 times 4, which is 2 to the 12th. That's what's happening. Hopefully you can see my 2. We have a rule: if you take 2 things and multiply them together and raise them to a power, you just need to put that exponent, that power, onto each of the things that are being multiplied together. So a times b to the n is a to the n times b to the n. Similarly, if you have them divided, same thing. You have to give that exponent to what's in the numerator and what's in the denominator. A very helpful one is taking something, it can be a variable, it can be a number. Raising it to a negative power is the same as taking the reciprocal. So for example, if I have 2 to the negative 3, that can be written as 1 over 2 to the 3rd. So what that does is it gives you a positive exponent. Sometimes, that's helpful since they're equivalent to use it with the positive exponent. Something that's really important to know is that anything raised to the power of 0 is in fact 1. So that could be, for example, 2 to the 0 equals 1. It could even be a variable. So x to the 0 equals 1. It's also true. And then the last 2 are basically just the same idea, except that now we're talking about radicals. So the m and the n are typically now fractions. So a lot of people know square root. So if I have, for example, the square root of 3, the idea here is that is the same as 3 to the 1/2. And that's because even though we don't typically write it for a square root because it's the one we see the most, there is technically a little 2 here. But again, we don't use it that much because square roots are the most common. For a cube root, though, we do put a little 3 there. And so if I had the cube root of 4, for example, that would be 4 to the 1 over 3. So notice whatever that number is, outside of the root, that becomes the denominator. The numerator is essentially just the exponent of whatever you have. So this is 3 to the power of 1, 4 to the power of 1. That is why the 1 is in the numerator of that fraction. And the last example is a the nth root of a raised to the m, and they're just showing you what the fraction is there that's created. So for example, you could have the fifth root of, say, 4 cubed. And what this rule is telling us is that another way to write this would be 4 to the, and then we have now 3 as our numerator, and then 5, of course, as our denominator. So that's just another way to say that. You know, it's another way to write it. And sometimes when dealing with exponents, that can be helpful. All right, so let's take a look at some examples. Okay, so you are always welcome to pause, see if you can do any of these problems, and then come back and watch me do them. Or if you get to a point when I'm doing a problem where you're like, oh, I think I can do the rest, pause it, go ahead and do it, see if your answer is right. The connections that that's going to create in your brain from the practice that you're doing yourself and then checking the answer is really, really going to be helpful. So I'll go ahead and start, but again, you can pause anytime. Work on your own at any time. Okay, so taking a look at the first problem, notice that it has all x's. We're only dealing with x in example A. And so now we're just using our rules here. So remember, when you raise, we have x as our base, to the power of 3, raised to the power of 2, a power to a power. Think about what we're going to do to those powers. We are going to multiply them. In the denominator, we still have x to the 4th. And then, now notice we have the same base, different exponents, but division in between them. So again, you can take a look at your notes there, and you can see that we're going to use this like quotient rule for exponents. That's telling us we need to subtract our exponents. Again, just remember that's because the numerator is x times x times x times x times x times x, and the denominator is x times x times x times x. So any of those common x's can be simplified, but it still leaves 2 x's in the numerator, specifically x times x, and so that's where the x squared is also coming from. The rules just make it a little bit easier. Okay, so now we have division here, but everything is inside the parentheses, raised to the 4th power. So we have, what you want to see is you actually have 3 pieces here. You have the 2, you have the x squared, and you have the y cubed. So every piece needs to get that 4, that exponent of 4. Now 2 is just to the power of 1, but it is still the same rule we used first in the last problem. When you're raising something, a power to a power, you're going to multiply. So we have 2 to the 1st to the 4th. So that's 2 to the 1 times 4, or 2 to the 4th. Then you have x squared to the 4th. And again, we're just multiplying 2 times 4 to get 8. And then in the denominator, we have y cubed to the 4th. And so we want to make sure we multiply 3 times 4. And that's going to give us y to the 12th. And typically, when you have a power to a power, like a base to a power like this, 2 to the 4th, it's not so huge. And so typically, we would write that out. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it would be typical to write this as 16 x to the 8th over y to the 12th. And there's no more simplification that we can do. We have an x in the numerator, we have a y in the denominator. There's nothing else we can simplify here. For part C, the best thing to do here, I'll do kind of the long version here, but just know that you can, once you understand this, and if you already do, then that's even better. But using the rule that we just saw up above, when you have, so x to the 4th, it's positive. In the denominator, we have x to the negative 3. So another way we can write that using what we know from above is 1 over x cubed. But this is now what's called a complex fraction. You have a fraction, and then you have a fraction within this fraction, because your denominator has a fraction in it. So a good thing to remember is that dividing by a fraction is the same as multiplying by its reciprocal. So we can change that division to a multiplication and then take the reciprocal of 1 over x cubed. Reciprocal is literally just the flip. So 1 over x cubed is x cubed over 1. So the reciprocal of it. And so we end up with this, x cubed over 1. But of course, dividing by 1 is just the same thing. And so now we see that we have x to the 4th times x cubed. And now we just use our rule, multiplication of the bases. We're going to add the exponents, and we're going to have x to the 7th. And then that's our final answer. So if you can kind of see the first piece, what we had for C, and then you see your answer, it's probably not surprising to see that, hey, if I just bring that x to the negative 3 up, I'm going to have x to the 4th times x cubed, and then I add my exponents. Okay, for the next one, what I would probably do to try to make my life as easy as possible, which we're all trying to do, I would take the reciprocal of the numerator. So notice it's to the negative 3. So I would rewrite that as 1 over x squared cubed. And then that would be over, and then I could do this if I want. I've got something to the power of 2. Notice you have two things multiplied together. So I have 2 to the squared, 2 squared, 2 to the 2, which is 4. I have x to the 4th squared, multiplying the exponents, is going to be x to the 8th. Now again, we have a fraction over in the numerator, and then we've got this other general fraction. So a good thing to remember, again, is, and I'll kind of show you how to streamline this, but what we're dealing with, and I actually probably need to think about where my face is going to be in this video, so I'll move down here instead. And the best thing to understand is when you divide by something, so notice we're dividing by 4x to the 8th. Dividing by 4x to the 8th is the same as multiplying by 1 over 4x to the 8th. Now, let me show you what this looks like. So in our numerator, we have 1 over x squared cubed. We can multiply our exponents. In the denominator, we have, I think I'm going to make that a little bit long. In our denominator, we have dividing by 4x to the 8th. So we're going to multiply by 1 over 4x to the 8th. And then we just multiply across. Now we have two fractions. Multiply straight across. So we just have 1 over, and then we have a 4. We usually put the constant first. X to the 6th times x to the 8th. We're multiplying things with the same base. Bada bing, we're going to add our two exponents together. So 6 plus 8 is 14. And here's our final answer. What I want you to see is you could have basically gone from here to here, or even just putting that all over 1 over that whole thing, if you understand that x squared to the negative 3 is the same as just putting that whole piece down into the denominator with a positive 3 instead of a negative 3. So that you have 1 over that whole thing. And then just simplifying it from there. I'm showing you kind of the longer version because we're using the rules here, but just understand that that is an option that you have because it does, work and streamlines the process. Okay, few more. Okay, so again, we're using the rules here. Often you can use the rules in different orders. Your answer is going to come out the same. So, pick a rule, do what you want, and you'll get there. Depending on what rule you use, it could look different. So you can go ahead and try these if you'd like, and then, unpause and see how you did. Notice here for E, we have negative, negative. Okay, I'll be honest. I do think that the best idea here is just to say, okay, I've got an x to the negative 2 in the numerator. That is the same as x squared in the denominator. X to the negative 4th in the denominator. That is the same as x to the 4th in the numerator. You're using the rules, but you're streamlining it so that you don't have to write a whole bunch of steps. So I think that's the best way to go, because that is true. Now, in the numerator, we have x to the 4th, dividing by x squared, dividing two things with the same base, we're just going to subtract the exponents. So notice I'm not even touching that 1/2 yet. It's coming up, here it comes. But first I'm just going to subtract my exponents to get x squared. Then I have x squared to the 1/2. You might see the 1/2, oh my gosh, I've got this fraction, what am I going to do? But it's still just the rule of multiplying our exponents. So we end up with just x. Because 2 times 1/2, or 1/2 of 2, is just 1. So it just simplifies to x here. How nice is that? For f, again, a couple different ways you could do it. I think the easiest thing here is just to have x to the 12th, and then I have that y to the -6. I want to make that positive. I'm going to bring it up. I'm going to make it y to the 6th, okay, because it's really division by 1 over y to the 6, which is the same as multiplying the fraction by y to the 6 over 1, which is just multiplying it by y to the 6, which is why I have that. But I don't want to forget, I also have this whole thing raised to the 1/3. And then, as we saw, we've got two things multiplied together. They both have exponents. Raising them to another exponent, all we need to do is just multiply those exponents. So in our situation, we have x to the 12 times 1/3. 1/3 of 12 is 4. We have y to the 6th raised to the 1/3. Multiplying 6 times 1/3 is 2. Can't do anything else. We have an x and a y. So then we're done. And the last one here, again, a couple different ways you can do this. This is how I'm going to do it. I'm going to understand that when you see something to the 2/3, just remember that that's the same as 2 times 1/3. 2 times 1/3 is 2/3. But if I break it apart like this, what it means is I can actually look at this as having two different exponents. I also have the negative, I have not forgotten about. But I'm going to write this as 27 to the 1/3, and then that to the -2. Okay? I don't want to blow your mind. But what you should see here is, if I go back and use my rules again, I'm raising something to the 1/3 and then to the -2. 1/3 times -2 is -2/3. That's what I have as my exponent. But now I have this as two pieces. The reason that I do this is because 27 to the 1/3 is the same as the cube root of 27. Now, the cube root of 27 is just, the way to think about that is there a number that you can multiply it times itself 3 times and give yourself 27? So is there such a number? 2 times 2 times 2 is 8. So the cube root of 8 is 2. 3 times 3 times 3, 27. 3 times 3 is 9. 9 times 3 is 27. So that tells us that the cube root of 27 is in fact 3. So now we just have 3 to the -2. And we know from our rules that that's 1 over 3 squared. And that's just 1 over 9. So 27 to the -2/3 is 1 over 9, or 1/9.